move your desk around a little bit. All right, here we go. This is 4.1, chapter 4.1, properties of exponents, rules of exponents. I'm going to do a couple different examples. I'm going to do them in different ways. I need you to pay attention to both styles. First of all, if you have a problem like this and it's 6 squared cubed, okay, your rule says power to a power, and power to a power you multiply, you get 6 to the 6, and then you multiply that out. Well, I'm telling you, if you have a problem like this and it's all numbers, the first thing you're going to do is pick up your calculator and figure it out with your calculator. Okay, because your calculator can do the problem 100% accurately, correctly. The problem is there's 3 different type calculators going on in here. You got the old one that's on the back of the door. We got the new one, right, which most of you have, and then some of you even have the Casios. So I'm going to go through this step by step. For most of you, you have the Texas Instrument, and I'm going to show you step by step what to do. If it were me, I would say parentheses 6 caret 2. This is caret. In computer science classes, we call this a caret. Okay, we had to program computers. That's 6 caret 2. Find it on your calculator. Then we're going to hit caret again, and we're going to say 3. Now, those of you with the new calculator, it's going to be a little different. It's going to do it for you. You can say 6 caret, hold on, clear, 6 caret 2, and it already put it up there for you. Then you hit the right arrow button to bring it down again, and hit caret, it puts it in parentheses, and then you hit 3. You've got to do it correctly in order to get 46,656.
I got it.
Try it on your calculator. Try it on your calculator and see if you get the correct answer.
Yes, sir.
Okay? Anybody not get the right answer? So I'm telling you, if the problem has all numbers, you're either going to be able to type it in your calculator 100%, or you can do parts of it with your calculator. However, you're going to have to know what to do is if this exact same problem presents itself and we now have variables, or letters as you would say, right? If all we have are variables and we don't have any numbers, we can't do this one on our calculator. So we go to our rules and we know that power to a power, what do we get? X to the 6th power. We multiply. When you got power to a power, you multiply. Okay? So each one of these examples I'm going to do with numbers that you can do on your calculator, and I'm going to do them with variables that you have to know how to do by hand. Okay? Questions? Because there's going to be both on the test.
There's an easier way to get that to where it says it. Just put 6x squared, then caret, automatically put both parentheses.
You talking about on the new one? Yeah, it does parentheses automatically. I said that.
Okay.
It does in parentheses automatically. All right, let's do this. 4 to the 5th over 4 cubed. Try that one on your calculator. All numbers, you can do it straight on your calculator. 4 to the 5th over 4 cubed. All right, you should get 16. Anybody not get 16?
You got 1.4.
Now do it again. 4 to the 5th. Use parentheses. If I come over there and you haven't used parentheses, I'm going to be mad. I've said it. All right, listen. Use parentheses. Okay? I've said it over and over. The new ones you don't have to as much. But you're never going to get it wrong because you put an extra set of parentheses in there. Okay? I know some of you are lazy and don't want to do parentheses, but they're not going to hurt you. You're going to get the problem right. Use parentheses. All right. Now let's talk about it as if it was a variable. X to the 5th over x cubed. Well, you need to understand that x to the 5th is actually how many x's? 1, 2, 3, 4, 5 x's. How many x's is x cubed? 3 x's. What happens to the x's? They cancel out, and I just end up with x squared. Well, I don't want to write it out like that each time. So what is a short way to go from this to this?
Subtract.
Subtract the smaller number from the bigger number. And x squared ends up on top because you had x to the 5th on top. There were 5 x's on top and there were 3 on bottom. So when you cancel them out, the x squared ended up on top. That's very important. Okay? Justin, how much time we got? Can you see? Cody, can you see where we're at?
We got 4:30.
It's at 4:30 or it's
Yeah.
at 6?
It's at 6.
Okay. Just let me know when it gets close to 10. Read.
So x squared over 1 is the answer. Just x squared.
I would just want x squared. Okay. It is over 1. It's understood to be over 1, but I would just want it to say x squared. Flip side, what if I had this? What would the answer be?
X 1/3.
1 over
X.
x cubed. 1 over x cubed. Why is it x cubed on the bottom? Well, the bigger number was on the bottom. Okay? And so I had to cancel. This is all review, I hope.
Yes, sir.
Questions? Any questions so far? Meg, you good? All right. Now let's get into something that's probably not review. I'm not 100% sure whether or not you had this or not. Let's talk about it with variables first. X to the negative 2. It's one of your properties you wrote down on the chart on page 107. X to the negative 2. Anytime we have a negative exponent, okay? Anytime we have a negative exponent, this stuff has to change places on the fraction. If it's on top to begin with, it has to come down to the bottom. So there's nothing left on top, so we just get 1 and we get x squared on the bottom. It was negative on the top. When we moved it and put it on the bottom, it became positive. What if it was negative to begin with on the bottom? What would happen?
You put it on the top.
It would come to the top, trade places, and become positive. I'm just putting it over 1 so you can see the parts of the fraction. Yes?
What if it's positive? Does it say positive when you move it down?
You wouldn't move it.
Oh, okay.
A to the 4th stays put. Let's say your problem is this. Right? A to the 4th, B to the negative 2. The only thing that comes down is that. That has to trade places. And so your answer would be A to the 4th over B squared, and you would be done. Okay? We're not there. Questions? Any questions? All right, I want to do some with numbers and let you type some in. And then, all right, here, this is a good one. 7 to the negative 4. 7 to the negative 4. See if you can figure out the answer to 7 to the negative 4. It's all numbers. You should be able to do it on your calculator. What's the problem?
It's negative.
It gives you a decimal, right? That's okay, but then when you try to change that decimal into a fraction, will it change it? No, it won't. On the Casio calculators, it will. Who has a Casio?
Oh, not
Anybody? I know Taylor has one.
sure.
You have one? Does it do it for you? So you got the answer right away. What was it? 2401? 2401. See, she went straight to the answer. Okay, now, hold on, you don't have to go out and buy another one. How do all us Texas Instrument users, how do we get to the answer?
7 to the 4th.
But we know that this stuff is going to come down to the bottom, right? And so it's going to be 7 to the 4th on the bottom. Our calculator will do 7 to the 4th, right? So we just have to be smart enough to do it in parts, and we'll still get the right answer. It may not go straight to the answer, but we can break it up and we can say, okay, that's 1 over 7 to the 4th, and so that gives us the answer. Does that make sense? Okay, good. Questions? All right, let's look at a few more. Let's do one without numbers that you have to do by hand. X to the 5th, y squared cubed over x to the 15th, y to the 8th. No negative exponents. That's the first thing you're looking for. How much time we
30 seconds.
I can't see the problem, Coach.
X, you got to move over. How can I move? X to the 5th, y to the 2nd, cubed over x to the 15th, y to the 8th. When it runs out, just let it run out. Don't worry. All right, so I cube and cube. That's one of our properties that you copied in the chart. Power to a power, that has to be distributed to the 5th, to the 5, and to the 2.
You add them?
So that becomes x to the 15th